Yeah.
We're going to get into some deep stuff today.
I like the
it's
deep
crazy.
stuff.
We're going to talk
Too
about
early
risk
to-
assessment today. It's a very boring topic, but it's extremely important if you want to be the guy or the gal who's going to put up a GMP facility. You have to do a risk assessment.
Yep.
In order to have a risk assessment, of course, you need to have a process. You have to have a process flow.
All right.
And you have to have your facility layout. That's why you hire us. Because we do all that
Exactly.
stuff,
Yes.
you know?
If you guys didn't know, we do all of that.
Yeah. And then we also help you with your risk assessment. We help you with your systems designation. We do contamination reviews for you. We have a lot of services that we do and we render on the GMP side.
Yep.
So we're very well known for our equipment. And obviously, when we put together a system for you, we're looking to put together the entire package, the information flow, the regulatory flow, all that
Just
stuff.
make it easy for people in the industry. So what better way than to have everything laid out for you, easy to follow.
Right, yeah. For those of you who haven't looked at it, we got free resources.
Tons of resources.
We got the podcast.
Yeah.
We got the product tools.
It's what do you want? Yeah, if you want to listen to stuff, you can also watch the podcast.
Yeah.
Sometimes we'll have to get in there for another lab day. I know that was one of our...
Yeah, we're going to get it. We're going to do lab days. We have about we have a little bit of time here. We're going to put together a very detailed GMP course for people. So we're working on that right now. We just got done with the business school stuff. So it's going to be interesting to see how that all goes.
Leads right into it. Yeah.
And then we're going to hit the lab. Well, we'll do that. That'll probably be towards the beginning of the year, maybe. So it'll be fun.
Something for people to look forward to.
Yeah, let's talk about risk assessment. What is it? What is it? What does this mean to you?
No, to me, when I think of risk assessment, I'm thinking of the things that could potentially hurt my business.
Yeah.
And that's essentially what we're kind of pointing out.
We talk a lot about risk of reuse of solvents, right?
Oh, yeah.
There's a huge risk there because you're contaminating again and again. There's people using chlorofluorocarbons. We're going to talk a little bit about that today.
It sounds dangerous.
It's a refrigerant. I mean, who cares if we put it up into the atmosphere? Doesn't really matter. It's not really ozone causing it. It doesn't really. There's nothing that will ruin the ozone layer with that stuff.
Oh, man. I don't know about that. All right. Well,
all right. Risk assessment is going to eliminate and mitigate risk to final products. It's a systematic method, of course, for doing that. And it applies to facility design, to the equipment, to the process, to the people, the facilities, all that stuff.
Okay.
And in fact, there's a really great guide that is accepted by the FDAs in the US and also in Europe. It's called the ICH Q9. And you can see those are all the Qs there. 1, Q2, Q3, all the way down to Q9. And it will go through a lot of things that I'm going to be talking about today. I'm going to be adding some specific color, what questions to ask and things that as you do your risk assessment. But at the end of the day, the quality risk management really is a part of a process that you really need to incorporate into your pharmaceutical quality system. It's something that you do all the time, right?
Yeah, they should be doing that.
Right,
again,
exactly.
Kind of knowing
why do we wear hairnets? Okay, because you don't want contamination, right?
Right.
Exactly.
It's got to have something in place. Yeah,
right,
help
exactly.
mitigate those risks. And most people think of it on that surface kind of level of hairnets, and they're not necessarily thinking of how their business is running.
One critical thing about contamination is you need to be able to measure it, right?
Yeah.
If you can't measure it, then how in the heck are you supposed to know,
how do you know it's
there,
there?
Right. That's the problem with chlorofluorocarbons, people. You can't measure that stuff very well. Yep. It doesn't have a chromophore is what they call it. So how are you supposed to measure it?
If you're not able to see it.
Exactly. Whatever. We'll get into that. Yep. Okay, so sources of risk. Obviously, process of manufacture itself. Yep. That's contamination from solvents, contact materials, degradation components. What if you heat the living daylights out of it and you change it from one thing into another? In fact, isomerization, that's essentially what we do with conversion of CBD into D8.
Okay.
We heat the living daylights out of it and we're changing the structure of it under, if your intended use was to create CBD, and you had a runaway reactor, and it didn't work, and you turned out, well, this didn't work. Oh, look, we have this other peak here. We don't know what it is. Oh, that's DA. Don't try the product. There's a lot of things that people try, and then you don't know. There was one of the myths that is out there is that the firefighting sulfur that caused the isomerization to D10, for example, which is how D10 was the process for creating D10 was. And interesting, I know back several years ago when the forest fires in California, that was, you'd oftentimes see all kinds of red stuff come out of the extract.
Really?
Yeah, because it was contaminated with the fire,
Like the ash, and then it landing on the
It
plant.
wasn't just
and then...
it wasn't ash. No, it was the firefighting stuff that they drop on the fields.
Oh, I see what you're saying. All right,
Yeah.
so there was an actual
It was like
chemical
red
responsible
stuff.
for it.
Yeah, exactly.
Man, that would be
Interesting.
Yeah.
But anyway, external contamination, obviously air quality, right?
Yep.
So usually you have ISO standards for the rooms, and that,
Yep.
that really drives up your air quality for external walls, floor, dust, hair, things like that. And then also systems, process fluids, coolant fluids, and lubricants and things that you would use in equipment and things like that. So sources of risk. We get involved in this a lot because obviously a lot of the manufacturers or people who are doing GMP process audits require that they look at specifically the equipment and what the impact of that equipment is on the contamination. So there's a contamination review. If you take all of these Q1 through Q14 and you did a search on contamination, it would probably be the number one word, repeating word that shows up in all of them.
Okay.
Because it's all about controlling the dosage form so that there's no contamination, so that your product matches your intended use. Okay, so that's what it is. Okay. Interestingly enough, you need to know what your intended use is, right?
Yeah, before you start. I
right.
mean, that would be a good idea.
Right. It wouldn't be a good actually to say, go into an FDA review and say, it turns out that D10 is actually a cannabinoid that's very whatever. So it's really not a contaminant. It's actually, that wouldn't be your intended use, right? Because you had your specifications, you had your quality specifications. What's great about D10 is that you can actually detect it.
Okay.
You can't detect fluorochemicals and chlorochemicals. Again, I'm absolutely appalled that people are doing that. They're using freons and things like that.
What would the appeal for something like that be?
Well, why would you use a refrigerant? The refrigerants is going to it's going to go out. You're going to have to vent some of it out in the atmosphere. It's going to outgas, right? Where's it going to outgas to?
Usually just the environment.
Okay, that's right. Okay, so X1. Okay, number 2, you get a contaminant in your stuff. How are you supposed to measure it? You can't measure it.
I got you.
That's what's so wonderful about it. You know, it's like, you can't measure it, okay?
Wonderful.
We do know that those types of chemicals like that can biomagnify. In other words, they can get into your endocrine system and very small amounts because they're not metabolized very quickly. I'm not saying all the chemicals are, but some of them are, and they sit there and they biomagnify, and then they can become toxic after.
All right.
Cancer's coming. Whatever. Can the risk be here? So here's some key risk questions. What are the categories of risk? How likely are they to occur? If they occur, what's the impact on product quality? Can the risk be eliminated? And if it can't be eliminated, how can it be mitigated to reduce it? So again, you're trying to find out, okay, you're going to look at all the different parts of the process.
Yep.
You're going to ask, okay, what are the categories of risk? Again, we get equipment, external,
solvent,
hair, spittle,
a little bit of spittle.
Yeah, and think that. And then if they occur, what's the impact upon product quality? In other words, are you going to be able to measure that? Yeah. So you would need to create a bunch of specifications that really looked at contamination and critical aspects of contamination. We're going to talk about all that too. Not all contamination is terrible, or you would say, okay, what's the impact to the product quality, and then what's the probability of that particular contamination, right? So you may be just sitting there fixated on something that's improbable, number one.
I see. Yep.
And it has no impact, number 2.
Yeah.
Then you shouldn't
wasting a lot of
time doing that. You should be talking about the stuff that are critical and
something that is actually going to affect that end product.
Yeah. There's a lot of different processes that different organizations have put out that are really great. There's the Hasep program, which is typically a food hygienics program or hygiene program.
All right.
And usually what it does is it looks at hazard analysis. It looks at the hazards analysis around, and then it defines critical control points for assessing quality.
Okay, so it's giving you places to look for,
right?
In your
you got to stop everything here, and we're going to test for quality.
Makes sense. They should be doing that,
Yeah, exactly. It's actually a process though, which is cool. So step 1, step 2, step 3, step 4. You go through your process, and you're following that Hasep process, and you're getting an output from that process, standardized output. So that's what's great about all of these. The GMP Hasep process also similar. FMEA, if any of you guys are engineers in the audience, I'm sure you've done an FMEA analysis. They could do fishbone diagrams and stuff. Okay, here's the main risk, and here's all the ancillary risk. Here's the failure modes, and people wig out on it.
Yeah, it sounds interesting.
Yeah.
I feel like I've seen them before, but
yeah, that's cool. And then you have the GMP process, which we use here for product realization and life cycle process. So there's risk assessment associated with that. In other words, here's a good example. What's the risk to the intended product output from the equipment based on the input parameters, which would be stainless steel 316 versus 304, for example.
Yeah.
Okay. So that would be one thing. For example, here's a good example. We just talked about that relative to the product realization process. No one risk assessment should be used for everything.
No,
okay,
here's
a good example that we deal with from GMP people that are not chemists. Okay.
Yep.
So we do an oil process, right? There's no acids. There may be fatty acids, but there's no acid halides in the process at all, right?
Those are the dangerous types
Yeah,
of
those are
acids
HCl, for example. None of that's in weed, in hemp,
Yeah.
and you're not even extracting that.
Okay.
Or any derivative thereof.
Yeah.
The important point there is that there's no probability. It's a zero probability
to create a risk assessment
that you would have an acid halide that then would corrode the equipment,
Yep.
thereby driving a specification that would be hardened, like being able to assess whether, or being able
Deteriorate
deteriorate it for HCl. Okay.
Yeah.
Okay. So you can see how it all comes down. You got
Right.
the risk. Okay.
And then how it's affecting.
Exactly. Okay. What people do oftentimes is they'll say, okay, I had this old risk assessment in the drawer that I did. I don't want to do the work again. So I'm not going to do the risk assessment at all.
Right.
So I'm not going to look at the impact. I'm not going to look at the probability of it. Okay. And I'm just going to say, oh, you have to have this particular Hastelloy material. And everybody's looking at you, what? There's no risk. There's no, blah, 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 blah.
Yeah,
You know,
when the risks associated
right.
with it.
Yeah. In the case of hemp, there's no risk associated for acid halide.
Yep.
So there's no need to have a 316. 316 is just as good as 304. They're both corrosion resistant metals.
Yeah.
Yeah. So
Yep.
anyway, I kind of digress there.
No.
Let's go on here. So the key topic really is intended use, and that is just the realization, the obvious. If we're making a sterile injection, that's not the same as a lotion, right?
No, I wouldn't think so.
They're different levels. So the intended use needs to go into the risk assessment, right? You wouldn't apply a sterile injection risk assessment to a lotion for eczema or something
Because
like
it's
that.
not going to go into the body the same way.
Well, it's not the
gonna have
intended
the
use. It's just
Yep.
a different level. So here's the risk assessment process. You got to designate your facility and define what is being manufactured there. Are you going to use it for multiple botanicals? Are you using it for one botanical?
Yep.
Are you going to have one output product? Okay, we're going to make the syringes filled with CBD, for example,
Yep.
or we're going to make one thing, isolate or something like that.
Yeah.
Then you do a process review. That's how, okay, we've done that many times on the show, but what we haven't done is said, okay, this is a critical process that can affect quality,
Yep.
or this is the critical process parameter that can actually affect quality. Then you have contamination review and you have the impact assessment. And I'm going to go through these. Again, this is just a really quick overview of the whole entire topic. The facility designation, we have a multi-use facility here. So
do a lot of different things. Yeah.
Yeah, so we do a lot of different things. It's either it's dedicated, it's multi-use, or multi-purpose. It's actually, for us, it would be multi-use because we do other botanicals here besides hemp. We do, and we have other things that we put out here. More or less the same process, but different outputs with different intended uses for each of those outputs and different
Right.
quality standards for each of the outputs. Okay, so
Makes sense.
so you would need to do that. Then you go through this process review. Again, once you got your facility figured out, what you're going to do with your facility, then you go through this process review. And typically you would start off with a process diagram. You'd get some material and people flows. We've done that before. We look at the chemistry here. We already talked about the intended use.
Yep.
And the output is this critical unit operation. Okay. So we take all this data, we got the process diagram and we
Yep.
got the material and we say, okay, well, that's critical because it's touching the API or it's touching the drug. So that's a critical process. And here you can see that this is not a critical process because maybe downstream, there's no possibility because everything's taken out downstream. So we can say, okay, this is critical. We're not really sure, but we're going to put it into the risk assessment and see whether or not we can make it so it's not probable or doesn't have any impact. Right?
You still want to quantify how much of a risk it's going to be. Even if it's...
exactly. So that's what the process review is about. Okay. And you do that for every process. So the chart that we have with all processes, you would do this exact same thing for every one.
All right. So
and
for
intake, this is critical,
decarb.
This is not critical, this is critical, this is not critical. Right?
Yeah.
I mean, that's what you do in this process review. So this is exactly what we're doing here. We have all of our process here. You can see this is the Q7 guidance that we're looking, and here we can see the unit operation assessment. So each of these are kind of unit operations, and we would do the process risk, we do the contamination risk, we look at the risk assessment, and then we designate the system as a direct, indirect, or no impact system. Okay, so this is what that process review gives you. Does it impact quality or does it not impact quality? That's really what you're looking for. Or does it have an indirect impact on quality? I don't know. Maybe the HVAC system, for example, in the level 1 area might have an indirect impact on the quality. Or something like that.
We're getting the chemicals out of the product, but it might still be in the room because there's an issue with the HVAC.
Right, exactly, or something like that. Or maybe it doesn't really directly impact it, but it has an influence on it. The temperature of the water. Okay, or maybe if you're doing process cooling or something like that. So something along those lines.
Gotcha.
Here's some review questions for you.
Oh, man.
This is where the rubber meets the road.
I didn't know there was going to be a test.
Oh, this is all test-worthy stuff here. Okay, will the input quality or variability impact quality? Okay, we're doing a talk tomorrow on mushrooms, and we're going to talk about that subject.
Nice.
So what that is, you have an input, right? It's variable, right?
Yep.
You have an output that is the effect on the psyche.
Yeah.
And it has a huge, the amount of the input is so variable, and the amount and the impact on the effect is so large that you really need to control the input. That's what we're going to talk about.
Oh, yeah.
And that kind of makes sense.
Absolutely.
I mean, a mushroom can be anywhere from 0.02 or 0.03 to several percent psilocybin, right?
Yeah.
Okay, you give several percent psilocybin to a whole bunch of different people all for the first time. They have huge impact.
Oh, yeah.
Differences in how they're
going to react to it.
Exactly. So will the quality variability impact quality? That's the contaminants, maybe the pesticides coming in your hemp. Impurities maybe from
dust
from
in the
solvents,
barn or
from
something.
The solvents. Okay.
Oh,
you're talking
there we
about
go.
the utilities. What happens if the process changes the API form? That's where we're talking about D10 isomerization or D8 isomerization, or maybe the chirality. Maybe you're looking to do a chiral separation, and it's just a different way to look at the molecule. Is it carboxylated or decarboxylated? That would be a direct impact system,
definitely.
Where it would change the form, the actual form. The acidic form of THC or CBD is not really very bioavailable. Without some sort of encapsulation, without some sort of chemical jujitsu, it's not really available for you.
Your body's just not made to uptake
That's why we decarboxylate it. So that's what happens when you burn it in a joint or something or a pre-roll. Okay, so what's the impact does the process have on the physical product quality? Can the API react? In other words, can the API, meaning THC or CBD, can it react? Is there side reactions? Does it have any impacts on that? So those are some very serious questions that have some good you want to take the chemistry data that you have from characterization and understand what happens. What are the degradation compounds? What happens? And does it make any difference? Okay, so CBN is a byproduct, a degradation byproduct of THC, right? Okay, so what happens? Yeah, it may produce CBN. Who cares? It may have an impact on your direct intended use, which may be
depending
instead
on
of getting high, they go to sleep. One of the two. Okay, but it's so you would have to address the probability of that happening under your conditions, and then you'd have to look at whether or not it had any impact on the product quality, and whether or not it really had any impact on the intended use. Okay.
Yeah.
So in that case, you'd want to say, okay, we're not going to cook the living daylights out of this. They do in decarboxylation post-processing, right? They cook the living daylights out of it. How much CBN you making in there, guys? I'm wondering. Okay. So doesn't matter. Whatever. Put it in there.
Yeah, they're just cranking it through.
Crank up it really smells bad too. You should put that stuff into a hood. Okay.
Oh man.
And then because all the terpenes are all reacting there, it's all black and everything. Okay. What in the heck are you guys doing?
No, they don't.
Forget about it.
Call this guy. You got to call this guy. We'll hook you up.
We'll hook you up. We'll hook you up
some
with our man,
processes.
Jared here. He's going to figure it out. Okay,
I will get ya.
can the product be recovered if things go wrong? That's the other thing. Okay, so the thought there is, hey, look, it doesn't matter if I cook the living daylights out of it. I'm going to put it through my short path. It's not a bad argument, okay? Not a bad argument, but if you want terpenes out, you wouldn't do that. But then they don't care about the terpenes. They just
Right.
buy the chemicals from Exxon and they just titrate them in. Yeah. Who cares about the natural terpenes anyway?
Oh man, no.
I'm
we got
just pushing all the buttons
No,
today,
that's all
aren't I?
right. They're going to be just coming at you with pitchforks.
Okay, yeah,
at
yeah,
MJ.
they're definitely going to be coming after me. They're going to,
Yep.
yeah, what they call that? They're definitely going to come after. They're going to be, yep, they are. Okay, I'm not going to leave. Of the process review. Okay,
Yep.
so here we did this process review. We just did a process review. Okay, we skipped over everything. But you
just
normally you'd
glazed
want
over
to
it.
just glazed over stuff. But you can imagine there's lots to talk about.
Oh, yeah.
So once you talk about that, you establish your critical steps, your critical operations, the ones that have an impact on product quality that you
Yeah.
already have your product quality, and then you define your process parameters. Okay, what the equipment specs are, what the operating range, and what the regulatory range is. Okay, so the equipment specs are usually typically tight. And then the operating range that could possibly operate in, you can operate from -10 to 100 degrees. Okay,
Yeah.
so that's a little bit wider,
A little bit more
and
leeway.
then sometimes the regulatory range. In other words, you'd want to even be wider than that.
Okay.
Now, if your regulatory range is very small and thin and it doesn't have, then you're going to have a hard time controlling the process, right?
Yeah, because
So you need to understand if that's the case.
All right.
If you have to control, you're making chocolate. Okay, you have to temperature controls are very important.
Oh,
right?
yeah.
Okay, that's it. So you have temperature controls. You got to do that. If you're going to make chocolate, you got to do that. So it's a tight window, and depending on the type of chocolate, all that
you
stuff.
can mess it up very easily.
You can mess it up easily, right?
Same thing with the oil.
Same thing with this. Same thing with the oil, and no different in your risk assessment process. Okay,
right.
This requires a process parameter that's very tight because we're going to be controlling this in the regulatory range. We're going to give to these guys is this big. We're going to have to really control it really tight. So does that make sense?
Oh yeah.
Yeah. Okay.
Yeah,
Risk
definitely.
assessment process. Again, a 4-step process: facility designation, process review, contamination, and impact assessment. We are on number 3. We are flying.
We're buzzing right
but
through
look,
this one.
I tell you, you could, theoretically, a guy or gal could take this, write down the questions, write the process down, and actually conduct a risk assessment according to this process.
You're
and it'd be totally legit.
Why are they gonna?
Be totally legit.
You're giving away the milk for
We're
free.
giving it away for free, guys.
Yeah, that's just
what
what
we're
we
gonna
do around here.
Besides that, with a little Q7 guy next to you, you can sit down with some popcorn. And
Oh,
some,
there you go.
Yeah,
Yeah.
be a good Friday night activity.
That'd be-
I mean,
hey.
who wouldn't want to talk about risk assessments?
Oh man.
Oh man, this is gonna be.
I think
this
smell
is why this is why I never go.
BizCon Friday night after party. We're gonna talk about risk assessment.
Risk assessments. Oh yeah, I wonder who'd show up to that one.
Oh man.
No, I probably would. I'd show up. Yeah,
Well, the ones that matter.
you probably
will show up.
wouldn't show up.
No, I'm.
You
no.
would definitely.
Yeah, I would.
Okay.
If you're gonna be there, I'm gonna be there.
Okay,
so
that's
there
it.
we go.
That's all there is. Okay, contamination review, guys. Here it is. Okay, facility layout, and then also the P&IDs, the equipment specs, the intended use of the API, those are the inputs, okay, that will produce levels of protection.
Okay.
Remember last time we talked about levels of protection? That'd be, level 1 would be the room we're sitting in right now. It doesn't have really any specifications on it. No wall specifications, no ceiling specifications, no lighting specifications, no floor specifications, no gowning specifications, no HVAC specifications. Specifications are all specifications. Let's talk about the
Specifications.
We need the specification of the specification, please. That's what we're trying to do right here.
Yeah?
This is the specification of the specification.
That's true.
Okay, so levels of protection, guys. 1, 2, and 3.
Yep.
When you create a level diagramma, which we're going to show you right at the very end, it's going to be really exciting.
Diorama?
Diagramma.
Oh, grama.
Yeah, whatever. Okay.
I was excited to see the little shoebox with the.
Oh, that would
risk
be even
assessment.
better.
Yeah, that's
would
what
be
I was
even better. You see the guy sitting on the table with a cup of coffee with his head down, sleeping. How many more? Okay, internal. Okay, so key questions for a contamination review. Okay, there's internal and external contamination. Internal contamination would be impacts from the equipment. Okay, is there a possibility of lubricants, or is there a possibility of process fluid, coolants and stuff like that getting in there? Or how about refrigerants, chlorofluorochemicals? Can they get in there? We wouldn't want that now, would we? No, we wouldn't. And then can cleaning impact product quality? So what are the impurities? Can you actually measure the impurities? Okay,
all right,
guys, you got to be able to measure the contaminants, period. And that includes the contaminants in your solvents, period. I don't know. I don't know. I just don't. I don't understand some people. Questions for the external risk. Now, external kind of gets into, it answers those previous questions that we just answered, but it also addresses probability and impact. And I had talked to you about that before. And the way you do the probability is, okay, you look at each process and you say, okay, is it open to the atmosphere or is it close to the atmosphere? If it's close to the atmosphere, the external, what's in the air is probably not going to matter. If everything's closed, if there's some open or briefly open is what they call it, open to the atmosphere. And unfortunately, within API facilities, and they have batch process, batch reactors, batch stuff, and you're moving things around. And even when you're getting the end product out, it's not fully contained all the time.
Okay.
So because of that, you need to really understand whether or not it has any probability of having a risk of contamination from the environment.
Okay.
Okay. So if you have outside air being pumped in and there's a bunch of birds on there, you wouldn't want that going into your system. So the risk impact then is, what is the type of facility?
Yep.
In other words, if it's contaminated, is it removed in subsequent steps, and are you possible to detect it? So those are the questions for external risk. And then the impact assessment. This is the final. We did that.
This is what it all comes down to.
What it all comes down to is you take those critical unit operations. You take the levels of protection. You take the systems, the facility systems requirement that come out of your risk assessment steps before, and you create system designation. Does it or does it not have a direct impact? And then you have, here's all your systems, and you write what the answer is to every one of those. Does it have an impact, or is it an indirect impact? And then that allows you to say this has to be controlled, commissioned, qualified, and it has to be under a certain level of protection.
All right.
That's it.
Yeah.
That's the impact assessment. Out of that, then you get an idea for levels of control. Okay. So here you can see there's a level 1, level 2, level 3. This would be a level 1 would be a normal situation, normal room. We had just said, no controls. Level 2 would be, they would have specifications on walls and roofs and probably gowning and things that. Level 3 would have levels of filtration, levels of control related to specifications on walls, specifications on what you wear, what you'd have to do, what you have to gown in. You can see in here, there's actually an air sink here, or what they call an airlock in between these two levels of control. So here's the door into these three. So it's going from level 1 to level 2 to level 3 through this airlock. And notice how the materials are separated from the personnel quarter. These are the general principles that we talked about at our last time. So this is really the output of a good risk assessment. You're going to get a risk assessment. It's going to be in the form of a spreadsheet. It's going to assess each process. Is going to have the process, what the risk is, internal and external contamination. It's going to have a assessment of whether or not it's probable and what the impact is. And then it's going to output this levels of control, just that.
All right. So you're putting all that information together, and it's just going to present itself to you. It's just a matter of putting it all there on paper.
So it's all coming together, and that's the basics of a risk assessment. And I think that if you want to learn more, obviously you can contact us. We can help you do a risk assessment. We can help you understand what all the impacts are. We can create levels of control drawings for your existing facility, do assessments that way. Yeah,
we can help as much or as little as you want. Some people take the reins on stuff and they just kind of need a little bit of help knowing where to go and how to navigate it, and that's where we come in.
And so that's why we're making the courses and things like that, and writing out articles and things that if you need to, hey, show me what to read, where to read, how to learn about it. That's what this is all about.
Yeah.
Hey, thanks a lot, guys. I appreciate your time. This has been Extract Talks, and it's been a good time. It's been a whirlwind tour.
This was good. James is still awake over there. I think it went pretty well. No, definitely.
All right. Sounds good. Thanks a lot, and take care, guys. See you later.
Bye.
Bam.